Okay, in this video we'll talk about tstats command in Splunk. Okay, so what tstat commands do, it basically performs a statistical queries on indexed fields, that means in tsidx files. Okay, so now one thing we need to understand what is tsidx files are and where they stored and in which cases this tsidx files generated before we go deeper into the command. Okay, so now first the question is the what is the tsidx file. Now tsidx files are time series indexed file. That means these files are created by Splunk by each unique word in our raw data with the correspondence reference to the events, so that whenever Splunk is trying to search those, suppose you run a search query like index equals to something, then some value, let's say some text, right? So how Splunk search internally, basically it first look into the tsidx files, okay, and see whether there is any reference for that keyword or not. Okay, then it gets the reference from the raw event from there and then picked up the raw event from the disk, right? This is the how the whole operations works. So this tsidx files and the raw event data that combinedly worked as a to create a index bucket or whatever index we can see in Splunk. Okay, so that means whenever we talk about a Splunk index, it's basically a combination of a tsidx file and a raw event data file. And the tsidx files is basically works as a index file. That means it's basically maps your each and every unique keyword in our data to a raw event data. Okay, now tsidx files also generates when we do a data model acceleration. Okay, now data model is a separate Splunk knowledge objects, right? So whenever you create a data model, Splunk internally creates a separate kind of index data. Okay, we will see like how data model is different, and if you want to know more about data models, I already created a video for data model previously. I'll be giving that video link as well here. Just refer that one. Okay, so we got a fair idea about what tsidx files are. Now using tstats, what are the data we can query? That means you are essentially talking about what are the different sources of tsidx files. Okay, now as I already discussed, normal index data always have a tsidx file. Now there is another option, data manually collected with tscollect command, but from Splunk 7.3 I think this tscollect command has been deprecated. Okay, and the accelerated data model. So we'll be mainly concentrating on the normal index data and accelerated data model mainly in this particular video. Okay, so we talked about what tsidx files are and what are the different sources which generates the tsidx files. Okay, now let us see one tsidx file. I just wanted to show you this one, so I'll just go to Splunk home, var log Splunk log var lib Splunk. So this is our Splunk db directory, right, where all the indexes data has been stored. Let's see our main index. Let's say default db is our main index, right? Now inside the default db there is a db folder. Okay, now if you go inside the db folder, this is the separate folder it creates for different time ranges, right? So these are the epoch time values over there. Okay, now if you see inside that folder, there is a file called tsidx file. Okay, now this is the file Splunk creates when you ingest some data into the index. Okay, based on the data available in the index, this tsidx files get generated. Now if you want to see the content of this tsidx file, there is a way to do it. Okay, I'll just show you that one as well. This is some kind of advanced Splunk concept. So from the command prompt, okay, first we will go to Splunk bin folder. Okay, so we'll go to our Splunk home, cd insert. Okay, now we'll go to bin folder. My caps lock is on. Bin folder. From here we'll run a command called Splunk cmd walklex. This is the tool to see the content of the tsidx file. Now you have to give the whole path of this tsidx file. I'll copy this whole path. I will, within double quotes, I will give this one, then slash the file name, the tsidx file name. I'll copy the whole file name here. Okay, then space, within space you have to give star here. Okay, so now if you see, this is the content of the tsidx file, and if I just show you in my Splunk index equals to main for all time. Okay, there are 12 events over there. If you see, there are some JSON events as well, there are some non-JSON events as well. For each and every event, it creates a key value. If you see it over here, it creates a key value over here. Okay, so this is how the tsidx file got generated. Okay, so it is good to know like how to see the content of this file. That's why I just wanted to show you this one. Okay, now let us get back to our main discussion on the tstats command. So basically the tstats command work on this tsidx files only. Okay, so that means it's only refers to the tsidx files and do the statistical computation on it. Okay, now if you see the syntax of it, like tstats, there are a lot of options over here. What I did is I did the color coding of it. Okay, that means if you see the similar color coding, that means those options are related. Okay, and now if you see this red color coded stuff, generally we don't touch this stuff. Okay, that's why I color coded it red way. Okay, red color. So if you see the green color stuff, that means those are the stuffs only the required part of this whole command. Rest of the stuff, everything is optional over there. Okay, so that means if I just go to our search over here and write a command called tstats. Okay, tstats count. Okay, now it supports, if I just open this screenshot over here, tstats supports a lot of aggregate functions. Now if you see this signature over here, okay, so and if you see there are a lot of options. These stat functions are mandatory, right? Now these are the stat functions are supported by tstats, and if you see my eval video, I have already discussed most of the stats functions over there. It works in very similar way. Okay, so that's why I will not just cover all of these functions today. I'll be covering some of it today. Okay, but these are the list of functions tstats supports. Now if I just write something like this, tstats count, okay, all time, let's see. If you see, it only returns the 12 events over here. Okay, and by default, if you do not mention anything over there, it works on the default index. Okay, now if I just go back over here, now there is one thing you have to remember over here. When we talk about tsidx files, right, that means the data which are already indexed, that means the fields after indexing the data, the available fields, only those fields tstats can work on. That means tstats will never work on the fields which created at search time. That means search time extracted fields will not work for tstats. Okay, so this is the thing you need to remember, that one. So that's why tstats, if you see the host, source type, those fields will definitely work for tstats. But if you are creating a field using a rex or something, that will not work for tstats. I'll show you an example as well for that. But before that, let us just see the syntax wise how it is working. And one thing I just wanted to mention over here as well, like as tstats work on only these tsidx files, right? It is comparatively more faster than stats command, because the stats command generally work on the on the output of the search command, right? So if I just show you something like this, I'll just duplicate it. Okay, so if I just write something like index equals to underscore internal, okay, then stats count by source, let's say. Okay, if you see this stats commands is actually working on the output of this guy over here, and this guy is not working on the tsidx files, right? It is working on the raw data, because if you see in Splunk search prompt, whatever search you run, it always there is a search command before that. This command is actually doing all the stuff in the search prompt. This search command is not needed, right? So that means that search command is actually working on the raw data to fetch the data. That's why the stats command is very much slow compared to tstats. We'll also see like what are the limitations of tstats, so that we can definitely understand which scenario what command to use. Okay, so we saw one of the use of this tstats commands is like it just accessing the normal index. Now if you see it over here, if you want to mention an index over there, okay, so what you can mention is through the where clause. Okay, where index equals to underscore internal. Okay, so if I just mention that one, now it is working on the internal index. So to mention an index you need to use the where clause. So if I just go to this diagram over here, so this where clause you can mention over there, and also after where clause you can mention a field value list as well. So if I just see this command index equals to internal, okay, and just see, let's say I'll just run that command. Okay, it's all time it is running, that's why it's running very fast, last 24 hours. Okay, and I'll just run this guy over here. Okay, and if I just say only these two source type I want, okay, something like source type Splunk D and this guy, so you can write something like this: source type in, okay, inside the bracket you have to give Splunk D, and then the health matrix. Okay, health matrices. So if I run this one, so you have an option to pass them as well. And if you want to use the by clause just like we use it in stats, right, you can do that. Even that's the clause name is by clause. If I just give by source type, so you can see only this two source type has been filtered and corresponding count has been shown over here. So we discussed the by clause as well, right? And in tstat by clause, even you can give time as well, that is our underscore time, right? And over there if you give time, you have an option to give a span as well over there. So if I just give a span, okay, so let's say 1 minute, or let's say 2 days, and we will just search here for last 3 days, let's say 3 days ago. Okay, to make it very simplistic. Okay, so even this is also you can do. Okay, so we talked about the by clause as well, the where clause as well. So where we need to mention to just to filter out which indexes we want. Otherwise it will always, if you don't mention anything over there, it will always work on the default index. Now there is an important clause called form. Now here the main sources of the tsidx files you can mention. Okay, namespace means either you can mention the tsidx file location. Okay, search ID, that means the tscollect job ID, which currently Splunk 7.3 version it is already deprecated, or you can give a data model name over there. Okay, so before we discuss the form clause, let me show you another stuff over here. Okay, so if I just go to index equals to internal, okay, so there is a field called group. Okay, so now this particular field is not indexed. Okay, so now this question came to my mind when I was basically researching this particular topic, is in Splunk how to know whether a particular field is indexed or not. It's basically like it's a search, that particular whatever field is showing up over here, it came from a search time field extraction or index time field extraction. There is no way to know in Splunk, and I think I found my answer. This could be like, this is by using the tstats command. Suppose if I write something like this, index equals to internal, okay, stats count by group. Okay, it always give me result, right? Because there are a lot of groups over there. There is a field called group. Now if I do the same stuff over here, tstats, so what will be my command over here? Tstats count where index equals to underscore internal, right? So that's my internal index. Now what I need to do, I already have in my count. In by clause I have to mention group, right? So if I just say by group and run this guy over here, let's see. So this guy I have run for last 24 hours. So I will just run this one for last 24 hours only and see. If that particular field is not an indexed field, okay, that means it's not a part of the metadata group, metadata, it will, tstats will always give you no result found for that particular field. But if you see the normal stats command, it's always give us the value or the output of that one. Okay, so this is one of the basic difference between a tstats and a stats commands, where stats commands work on both index time field extracted fields and the search time extracted fields, but tstats will always work on the index time extracted fields only. Okay, now let us concentrate on the data model part over here. Okay, so if you see the color code of the data models, there are couple of options like allow old summaries, and then summaries only is equals to true or false. These three things are related over here, right? So that means these three things will be coming into picture when we will be having a data model in our form clause, right? Now one thing you have to remember is, when a data model comes into picture in the form clause of a tstats commands, okay, the tstats commands that access only tsidx files only when a data model is accelerated. Okay, when a data model is not accelerated, there is no tsidx file has been created by Splunk. So in that case, if you, even though you apply tstats command on that particular data model, that will be working as a normal search command itself. Okay, so you will not get the performance benefit of the tstats command. To show that, let's see if I just duplicate it over here, and if you know, if I just go to settings and data models over here, when you install Splunk, two by default data model has been created by Splunk. Okay, one is for internal server logs, another is for internal audit logs. So if I just go inside the internal server logs, so there are a lot of nodes about this particular data model, like scheduler, acceleration, licensor. So if you want to know more about data models, I already created a video for this one. Please refer that one. I'll be giving that video link as well over here. Okay, and if you see, this is the data model logical name, right? Now if I just run a command, something like tstats count, this is the two mandatory stuff we need, right? Then form data model equals to the data model name. Okay, so what is happening over here? If you see it gives you a count, but in that case this particular data model is not accelerated. If I just go back over here, okay, if you see the acceleration is not turned on over here, right? See, if I just, sorry, not this one, this one, if I just go to the acceleration is not turned on over here, right? So in that case the normal, this query performance will be same as if you run a normal search on the database, something like using a database data model command, right? So if I just run a command something like data model, then the data model name, then the search, right? So it will be something similar to the performance of this particular query, then stats count to get the whole count over here. But whenever we accelerate a data model, right, in that case the actual performance benefit of the tstats command we will be getting. In that sense, now I just wanted to discuss this guy called summaries only equals to boolean. That means if you accelerate a data model, that means the data model summary has been created, right? That means the tsidx files has been generated for the data model. In that case you can mention it over here. You just want to access the summary data. So if I just say over here summaries only equals to true, okay, I know my this particular data model is not, it's not accelerated till now, so that means this guy should not give me any data over here. If you see, this is giving me count equals to 0 now, because we are only trying to access the summary data, and this particular data model is not accelerated, that's why this particular query is not giving you any data. Okay, so we will see after acceleration of this particular data model how this particular query is giving you result. Okay, so, and if I just discuss the another one, the allow old summaries equals to true or false, that means suppose you have created your data model, then after a certain time and you accelerated your data model as now, at certain point of time you change the definition of the data model. That means you added some more child elements over there. Okay, in that case the definition of the data model has been changing over there. Okay, in that case after you change the data model again, you are enabling the summary, right? That means there is data model acceleration. It will create an old summary, new summary as well, right? Now if you want to still access your old summary, you have to use this particular option over here, allow old summaries equals to true or false. Okay, in that case the data will be fetched from both the new changed summary data and as well as the old summary data. But you have to be very careful over here. If you need to do it only when you are sure that your old summary data is good enough to generate the data. Okay, so we talk about some of the options over here, actually most of the options over here related to data model. The two other options like local equals to true or false means if you make it true, that means this particular the query will be mostly running on the search set, otherwise it will be running on the indexer. Okay, and the chunk size is the size of the tsidx files. It will be read by Splunk. Okay, so ideally you should not be changing this one. Now there are two important input over here, pre-stats and append. Now what is pre-stats? As the name suggests over here, if you see the pre of the statistics, that means if you say pre-stats equals to true, okay, so what will happen is whenever we say pre-stat equals to true, Splunk generates the data in such a way so that it can be consumed by the statistical functions like time chart, stats, charts command. Okay, so internally Splunk creates a data structure something like that, or the output something like that. Okay, and append equals to true, we will see that use case as well today. Okay, so before that, okay, let me show you that one. So before that, what I will do is I'll just make this particular data model, I'll just turn on the summary. Okay, so I'll just go to edit acceleration, so that whenever the summary is building, in between we will talk about the pre-stats and append. Okay, So summary range, let's say 7 days. Okay, save. So it is currently building the summary. If I just see it over here, the status is building over here, how much space it is taking. This is all this information, it will be showing up over here, right? And if you see the tstats, we are basically relying on we are basically taking a trade-off between a CPU usage or the disk usage over here. Okay, that means our search will be more faster, but the data needed for my search will be taking more space, because tsidx file will be taking more space compared to the raw event data. Okay, so okay, we'll come back to this particular accelerated data model, because we will be running this search again to see now the summary is only equals to true will be working. Okay, so now we will work on the another search window over here. Okay, so you are talking about the prestats and the append one, right? And prestat, as I said, like it will be creating a data which is consumable by the statistical functions. For that, what I will do is, so there is a use case. Okay, the use case is, let me show you the data model over here. Okay, so if I just see this particular data model which we were working before. Okay, so if you see, now there is a sub node for this data model is REST API calls, right, which is basically having all the logs it is taking up, right, and restricted to the Splunk access log. Now for that, again, it has a child called job endpoint, and if you see it over here, it's the job endpoint is filtering only the services/search/jobs URI paths. Okay, so if I just wanted to see what is the total number of API calls, and among them what is the total number of job API calls, if I just wanted to see that report, how I will see it? Through tstats command. Okay, so that's the use case over here. Okay, so first thing is, we need to build a report. First we need to get the count for the total number of REST API calls, right? So for that, what I need to do is, so this is, we need to access the data model first. So that means if I just write tstats stat count from data model equals to internal underscore server, right? So that's our data model name, but we need to access its REST API calls this particular node, right? This node name is Splunk daccess, and it is under the root node Splunk server, that is the server. That means this is how we access the node of a data model when we use a tstats command. It's called where, okay, node name equals to, okay, node name equals to this server. Okay, this is the logical name, right? Sorry about the noise, there is a crazy dog barking outside. Okay, server dot the node name over here, which is our Splunk daccess, right? So if I just run this one, so I'll be getting the whole count. So let us run this one for last 8 days. I know for 8 days there is a job access over there. Okay, so 8 days ago, so this is the count, right? And if I just take this particular count, let's say I'll just create a new field called count for. Okay, I'll tell you why I am creating this one. Okay, so this is required for the whole logic creation. Okay, so then again, now over here, one thing I have to do is we have to mention prestats equals to true. Okay, so here is the catch over here. Now generally tstats is a reporting generating command. That means it has to be the first command in the search string. Okay, whenever you are mentioning a tstats pre-stat equals to true, it becomes the event generating function. Okay, that means it can appear in latter part of the search string as well, which we will do it now. Okay, so we will run another tstats, okay, command over here. Now we will access the count for this job endpoint level as well. So what we'll do, we'll just copy this guy over here, then dot the job endpoint. Okay, so in first tstats command, what we are doing, we are calculating the count, the overall count at this level, the REST API level. That means how many overall count has been there. And the second tstats command, what it is doing, it is calculating the count at the job endpoint level. That means how many search job endpoints has been called, right? So now over here I need both of this count. That's why over here I have to give append equals to true. Okay, so this is important over here, because I need to build a report with both of this count, right? That's why I'm giving append equals to true over here. Okay, now if you see it over here, after this particular tstats command run, this I have given this count for equals to total, right? So now that means whatever data has been generated internally, Splunk generated. Okay, so this all those data has this count for is total. Now the new data has been generated as well, right? Now for that I will be having a count for a separate, let's say, job endpoint. So for that I will be writing this kind of statement. So I already written it over here. It's a very simplistic logic over here. What I am doing, I am checking for whether my count for is null or not. Okay, if it is null, then I will be replacing by this one. That means for these guys it will be still null, because this is the new data I have added to this whole data set, right? So for them the count for value will be search API, and for others the count for value will be total. Okay, now if you see, I just wanted to show you how the data internally looks like. It is some kind of format which is consumable by the other commands. If I just now chart count by, okay, count for, if I just do this one now, it will be more easier. If you see, now the total and the search app API has been coming up over here. Okay, even though the internal, if I just remove this chart command, the internal representation of the data is not readable by us at all, right? But it is consumable by the chart command. That's why this pre-stats equals to true comes into picture over there. Okay, so now one thing we have to remember over here. Okay, and there is an analogy of this one with the summary index. Okay, so where, if you remember from my summary index video, the way we push the data to summary index, the same way we read the data from summary index as well, right? Summary index just work like a black box. So this is similar concept over here. The statistical function we use to generate the data, the same statistical function we'll be using for the command which is consuming the data. Okay, so this is important over here. Okay, so this is how the pre-stats and the append stuff works over here. Okay, now let's see whether our data model has been already completed or not. Okay, it is 100% completed acceleration. Now I will run this guy over here. Previously it was showing me 0 count, right? Now it should show me some count over here, if you see, because of this summary is only equals to true. Okay, I just wanted to demo that stuff over here. Now let us go back to our diagram over here. So we talked about in very detail about all the different syntaxes of tstats. Now advantages, as I already told you, it's faster than stats because it's working on the tsidx file. Okay, while stats working on the raw data. Now one of the disadvantages you can think of it is, like, as I already said, tstats only work on the indexed metadata. It cannot work on the fields which is basically created because of the search time field extraction. It cannot work on that, and it uses more disk space. That's the trade-off we have, right? Because CPU, we are basically getting faster access by using more disk space. And the limitations, if you see, now tstats is really good for aggregating values and reducing rows. That means if you say in tstats commands, if you group by underscore time and you give just 1 second over there, ideally you are expecting each and every event, right? If I say your events are generating every second, so in that way ideally you are not reducing any rows over there, right? So even though you can trick tstats commands to do that, but that will actually hamper the performance of the tstats. So but so for an example, if you see it, we have an example over here as well. If you have 10 million rows in a data model and your tstats is grouping everything by time span equals to 1 second and returning 8 million rows, then it is not a good way to use tstats. But if you are having 10 million rows and it is returning only 1000 rows, then definitely it's a good use case for the tstats. Okay. Now the tstats command does not support any wild case character in the by clause. That means you cannot give in the field name, basically you cannot give like any star in the field name over there. Okay, so this is not supported, and we cannot use any complex eval statements inside the aggregate function like count eval, something like that. It is not supported at all by the tstats. Okay, so hopefully this video is helpful. We just have a brief, or I think very detailed overview of the tstats command. It is one of the important command in Splunk. Okay, so in future videos we will see more other Splunk commands as well. Okay, see you in next video.